Now we're going to continue our lesson on logs, and we're going to simplify logarithms using our understanding of exponents. And what we need is this number here to be a 2, because we're trying to just simplify this. And if they're asking us to simplify it, what we're really being asked to is have log base 2 of some number, 2 to raise to some power x. Okay? Because again, in the last lesson I explained that this is really asking you 2 to what power gives you 8. Okay? And so if we could reduce it so that it's the same base, then we could say that the answer is whatever that number is up top. And hopefully you know that 2 to the third power is 8, so really this is log base 2 of 2 to the third power. So the answer again is the exponent of which I would raise the base 2, which is 3. 2 to the third is 8, and I could replace it here with 3. Okay? So the question on the second one is 10 to what power is 10,000? There's a nice trick with anything with zeros, 10 to zeros. If you just count how many zeros you have here, because there's 4, this is really 10 to the fourth power. So I would raise 10 to the fourth power, and that would give me 10,000, which means my answer is 4. Okay? And so I could have rewritten it as log base 10 of 10 to the fourth. The bases are the same. The answer then is the exponent. Okay? So now we get into ones that actually give us properties, because I have my base is the same here, so it's log base b of b. So what power would you raise b to get b? Well, it would just raise it to the first power. So the answer is 1. Okay? Well, here on the second problem, it says simplify log base b of 1. Well, b to what power would give you 1? Well, anything to the 0 power is 1, which means that x has to be 0. So it's really log base b of b to the 0 power, because b to the 0 is 1, so my answer is 0. Okay? And so that's a helpful little trick in subsequent problems on this next slide. Here we'll see log base 7 of 7. 7 to what power is 7? Again, that's the question we're being asked. Is 7 to what power is 7? And the answer is 1. In this one, 9 to what power is 1? Well, anything to the 0 power is 1. So the answer is 0. Okay? And now we've got 0.2. Uh-oh, we've got log of a decimal. Well, it's just log 0.2, base 0.2 of 1. Well, what do you raise 0.2 to get 1? And that answer is 0. Anything to the 0 power is 1. So this is 0. Okay? And finally, this one is a little bit more complicated. We've got 8, log base 8 of the cube root of 8. Well, the question is 8 to what power equals the cube root of 8? Well, we need to understand that the cube root of 8, hopefully you remember, is really 8 to the 1/3 power. Because if you have a root, it goes on the bottom of a fraction and the number on the inside goes on top. So really this is just 8 to the 1/3. If it was the fourth root of 8, that'd be 8 to the 1/4. Okay, hopefully you remember that from much previous lessons in Math 095. And so you should get the exponent, so 8 to the x. So what power would you raise 8 to get 8 to the 1/3? And the answer is 1/3. Okay? So these are all simplifying using properties. Now we're going to get into solving log equations. And we're solving because, of course, there's an equal sign. Well, whenever it's actually a log in log form, you never actually solve it as a logarithm. Whenever you're solving a logarithm, you actually go exponential. Okay? Whenever you've got a logarithm, you have to go exponential to solve. In other words, you're supposed to do that circle pattern. Okay, and we do that by starting at the 3, the base, and raising it to the 22nd power. So 3 to the 22nd, and then from the 22nd you go over to the last thing, which is the x. Okay, and so that equals x. And we just solved it. We got x by itself. And who cares what 3 to the 22nd is? Huge. We don't actually care. It's just 3 to the 22nd is actually x. So if this first part wasn't very clear, this was actually, and it's kind of hard to see there, it's log little 3 of x equals 22. So I went from the 3 to the 22nd, and then x was left over. Okay. Now we've got log base x of 5 equals 1/3, so we need to isolate the x. Now in this case, it's a little bit unique. We're going to have a second step. So we start with the x, raise it to the 1/3 power. So I got x to the 1/3 power. And then we say it's equal to 5. Well, x is not all the way alone. We have to completely isolate the variable, so we need to get rid of this 1/3. Well, to get rid of a 1/3, you need to raise it to the 3rd power. So again, if it's up to the 1/3 power, you need to raise it to the 3rd to both sides, and that will cause this fraction to cancel, and I'll be left with x alone equals 5 to the 3rd, which is 1/25. So that's solving logarithms. Again, whenever you solve a logarithm, you actually convert it to exponential form. You go exponential using the circle pattern first. And of course, we get even more complicated yet, but we're still doing the same process. Whenever we're solving logs, we have to go exponential first. Okay, so that means we start with the 4 here on this first problem. It's log base 4 of 2x plus 4 equals 3. Start with 4, raise it to the 3rd power, so it's 4 to the 3rd equals 2x plus 4. So it's not as bad as it first looks. It's just a regular algebra problem with 4 to the 3rd in it. So you just work out your 4 to the 3rd, and you should end up with 64 equals 2x plus 4. And you just have to isolate the x by subtracting 4 from both sides, and you get 2x equals 60. Divide by 2, and you should get x equals 30. Okay, so not as bad as it first looked. Let's do the second one. So this one's log base x of 125 equals -2. So we just take the x, raise it to the -2 power, x to the -2 equals 1/25, 1/25. So this time, notice the x has a -2 exponent. So it's almost by itself, but not quite. Well, we can't square root it, because that's what we almost want to do to cancel it out, but you can't because it's a -2. So what we actually have to do is rewrite it to be 1/x squared. Because if we have a negative exponent, we need to put it on the bottom so it's a positive exponent, because we would like to actually square root this, and that's equal to 1/25. Now at this step, there's a couple things you can do. Well, first of all, we don't care that the tops are both 1s. We just care about x squared and 25. So notice the tops are the same, which means that the x squared has to be the same as the 25. So we could just actually ignore this and write x squared equals 25. Or another way of looking at it is, since they both have 1s on the top, you can actually flip both fractions over and write x squared over 1 equals 25 over 1. But regardless, you end up with x squared equals 25. So to finish, now we can square root, and we get x equals 5. The square root of both sides, you get x equals 5. Now technically, if you remember when you solve by square roots, you would get a plus or minus 5. But because it's a logarithm, we'd end up with a log of a negative number, or a log with a negative base. And if you tried doing log of a negative number on your calculator, if you just tried pushing like log -5, you'd end up with a really weird answer, because you can't do logs of negatives like that. Okay, so we just take the positive answer, and we get x equals 5.